We're moving now into our first real biochemistry chapter, and I like to call this acids, bases, and buffers. One thing I want to do at the beginning of each new unit is talk about our goals, and I've shown them for this unit right here. There's two real big important biological questions that we want to answer in this chapter. The first one is, how do you predict when a molecule is protonated or not? I'd also like to tell you why we care about such a thing. We talked about the protonation state of acids and bases a little bit in our functional group chapter, but I just want to take a moment and let you know why this is so important. Here are two drugs of great biological and clinical interest: aspirin for headaches and fever and things like that, and lidocaine, which is a topical anesthetic. We mentioned earlier that aspirin has a carboxylic acid, and it can give up its proton, and when it does so, it goes from neutral to fully negatively charged. Likewise, with lidocaine, it has an amine on it, and that amine can pick up a proton as a base, and when it does so, it becomes positively charged. Why do we care whether they're protonated or not? The answer is because the charge of a drug can greatly affect how it acts in the body, and we're going to use these examples a little later on. So that's part to come a little bit later. The second big question we have in acids, bases, and buffer is, how does the body maintain a constant pH? Maybe you know what the blood pH typically is. It's about 7.4 in a healthy person. If you go much below 7.3 or above 7.5, you got real health problems. How does the body maintain a pH of 7.4 in the blood? The answer to that question is buffers. The body uses buffers to maintain the constant pH throughout, and particularly in the blood. So this is where we want to start with question 2, and in order to do that, we're going to get into the definition of a buffer. This is not something you need to memorize. Think of this more as an outline for where we're headed. A buffer is a roughly equal mixture of a weak acid and its conjugate base. That's the first half. A roughly equal mixture of a weak acid and its conjugate base that can neutralize added challenges of acid or base and maintain a constant pH. That's our goal. Let's think about it in the blood. We want to maintain that constant pH of 7.4, and if we throw acids and bases at it, for instance, if you eat some pickles or something like that have vinegar in it, you're throwing acid in your body. How do you maintain a constant pH? Well, let's pick it apart on the next page.